Hello and welcome back to Simplimath. I'm Reshu, your maths teacher, and I have a bachelor's and a master's degree in mathematics. I'm helping you here to cover every concept, every example, and every question from every exercise. So when you subscribe to the channel, you get access to all this knowledge, which will help you prepare for your exams better. In this video, we are going to cover example number 2. So let us begin. Example 2 says graphically find whether the pair of equations has no solution, unique solution, or infinitely many solutions, and these are the two equations that we are given. So like we did in example 1, we will first understand a little trick so that we don't make the mistake in exam. So let this be equation 1, let this be equation 2. So equation 1 is 5x minus 8y plus 1 equal to 0, and equation 2 is 3x minus 24 by 5y plus 3 by 5 equal to 0. So when we multiply this equation number 2 by 5 by 3, what do we get? Let's see. We get 5x minus 8y plus 1 equal to 0. Now you note over here that equation 1 and equation 2 are same, right? And also when we take a1 by a2 equal to 5 by 5, which is equal to 1, b1 by b2 equal to minus 8 by minus 8, which is equal to 1, and c1 by c2 equal to 1 by 1, which is equal to 1. So I can say that a1 by a2 equals to b1 by b2 equal to c1 by c2. So this is possible when there are infinitely many solutions. We have already done in section 3.2. And this means that the lines, when we plot these two equations on the graph, we get that the lines coincide each other. All right. So now let us see how we have to proceed in the exam. So this is equation 1 and this is equation 2, right? So equation 1 is 5x minus 8y plus 1 equal to 0, and equation 2 is 3x minus 24 by 5y plus 3 by 5 equal to 0. Now let us multiply the second equation by 5 by 3. So we get 5x minus 8y plus 1 equal to 0. So this is equation 1, this is equation 2. We know that both are same, so they are coincident, and this implies that there are infinitely many solutions. But in exam, what you have to do, you have to plot the points of for both these equations. So now let us come. We know that both of these are same, so I can say equation 1 and equation 2 are same, so they are coincident. Therefore I can say 1 and 2 have infinitely many solutions, right? And when we plot, let's plot the points for equation 1 and 2. What do we get? Let's say this is x, and we know that from here or from here, y, the value of y would be 5x plus 1 by 8, right? So when x equal to 0, y equal to 1 by 8, when x equal to minus 1 by 5, y equal to 0. Now let us plot these points on the graph. Alright, from here we can say 1 by 8 equals to 0.125, and minus 1 by 5 is equal to minus 0.2. Okay. Now on the graph, if you notice, I have taken two of these squares value to be 0.1. Alright, so when x equal to 0, y equal to 0.125. So now let us see, x equal to 0, y equals to 0.125. So this is 0.1, this is 0.2, this point is 0.15, and 0.125 would be the midpoint of 0.1 and 0.15. Alright, so this is the point. Now when x equal to minus 0.2, then y equal to 0, so it is this point 0 point minus 0.2 and y equal to 0. All right, so when we connect these 2 points, we get the graph of the equation 5x minus 8y plus 1 equal to 0, right? And the second equation is also same. So when we plot its graph, this is also same. So I can say the two lines are coincident, which means that the pair of linear equations have infinitely many solutions. Now I encourage you to try the same technique with another pair of linear equations, which is x minus 2y plus 6 equal to 0 and 4x minus 8y plus 24 equal to 0. I want you to try for this pair of linear equations and to find out if the pair of linear equations have no solution, unique solution, or infinitely many solutions. If you have any queries, leave them down in the comment section below. If you like the video, subscribe to the channel and share the video with your friends.